Hi everyone, welcome to the second part on data manipulation. In the last session, we talked about how to import, store, export, and clean data. Today, we're going to move forward and explore how to organize and aggregate data, two essential steps that help us get our data ready for deeper analysis. Organizing data is a critical first step before any meaningful analysis. It helps turn messy or raw information into a structured format that's easier to explore and understand. Why is it important? Improved accessibility. Well-organized data is easier for people and systems to read and interpret. More accuracy, fewer errors. Standardizing data, like fixing formats or sorting, makes it easier to catch and fix mistakes early on. Better analysis. Most tools require your data to be in a tidy format with consistent labels and values. Supports collaboration. When your data is structured clearly, it's easier for others to reuse and verify your work. Faster processing. Structured data can be processed more efficiently, which is a big deal when working with large datasets. Data integration. Organized data makes it easier to merge or join multiple sources. Clarity. Clean data structure helps everyone, technical or not, understand the relationships between variables. There are several practical techniques we use to organize data: sorting, filtering, slicing, transposing, appending, truncating. Let's take a closer look at each. Sorting is basically arranging your data in a certain order, either from smallest to largest, or what we call ascending, or from largest to smallest, which is descending. Doing this helps you see patterns more clearly, or just makes it easier to find what you're looking for in your data. For example, imagine you're putting together a monthly sales report. You might want to sort all your transactions by date in ascending order. That means the oldest sales will show up at the top and the newest sales will be at the bottom. Here, the date is the key factor you're using to organize your data. By sorting this way, you get a clear timeline of sales activity, making it easier to track progress over the month or spot any unusual spikes or drops. Sorting helps turn raw data into a story that's easier to understand. Filtering is a way to zoom in on just the parts of your data that matter to you. Instead of looking at everything, filtering lets you pick only the rows that meet specific conditions. For example, imagine you have a table of customer orders. This table has customers from different states, say Ohio and California. But maybe for your analysis, you only want to focus on customers from Ohio. So what you do is apply a filter on the state column and tell it to only show rows where the state equals OH. Once you do that, your dataset will shrink to just those Ohio customers. So instead of seeing everyone, you'll see only the customers like John and Sam who are actually from Ohio. This makes your work easier because you're concentrating on exactly the data you need without distractions. Filtering is super helpful when you want to answer questions or spot trends about a specific group within your bigger dataset. Now let's talk about slicing. Slicing means selecting specific rows or columns from your dataset, usually based on their position. This is different from filtering, which is based on conditions, like showing only customers from Ohio. Slicing is more about location. For example, if you want to look at just the first two rows and the first two columns, that's slicing. It's a great way to quickly zoom in on a small section of your data, especially when you're just exploring or checking structure. In the example here, we start with a dataset that has 3 customers and 3 variables. If we only want to see a portion of it, we can slice out the top left corner by grabbing the first 2 rows and first 2 columns, almost like cropping a picture to focus on one part. Next up is transposing. Transposing means flipping your dataset so that rows become columns and columns become rows. You can think of it as turning the table on its side. This is really useful when you need to switch between what's called a wide format and a long format. For example, imagine you have a table where each row represents a year and each column shows sales for a different quarter. If you transpose that table, now each column becomes a year and the rows show the quarter by quarter sales. It's a quick way to reorganize your data, especially when a different format makes it easier to analyze or visualize. Appending, also called concatenating, this is how we combine data sets that have the same structure by stacking them vertically, meaning we're adding more rows. For example, say you have two tables, one with sales data for quarter 1 and another for quarter 2. When you append them, you're basically stacking quarter 2 right below quarter 1, so you can analyze the entire first half of the year together. One thing to watch out for: the columns in both tables need to match, same names, same order, otherwise you might get errors or misaligned data. Truncating means shortening your data, either by cutting off characters, values, or even limiting how many rows or columns you keep. For example, let's say your system only allows 50 characters in a transaction description. If the description is longer than that, it gets truncated, meaning anything beyond the 50th character gets cut off. This is different from slicing, where you're choosing a portion of the data to view. Truncating isn't about selection, it's about cutting data down to fit a limit, whether that's a technical constraint or a formatting rule. Aggregation is about combining and summarizing data so we can see the bigger picture. Instead of looking at every single record, aggregation helps us group the data to spot patterns and trends more easily, especially when working with large data sets. For example, if you have millions of transactions, it's not practical to go through them one by one. But if you sum up total monthly sales per customer, you can quickly understand spending behavior without getting lost in the details. Aggregation also helps uncover trends that might be hidden in the raw data, like if you group daily website visits into weekly or monthly totals, it becomes easier to see long-term growth or seasonal spikes. It's also super useful for decision making. Executives usually want quick metrics like total sales or average customer satisfaction, not a giant spreadsheet. Aggregated data makes it faster and easier to generate reports or dashboards. Another benefit: it improves performance. Summarizing the data cuts down the amount of information your tools need to process, which is important for real-time analysis. For instance, showing total inventory by product category instead of listing every single item. Plus, aggregation lets you compare across groups like by age, gender, or region. Say you're looking at student test scores. Instead of reviewing every score, you can look at average scores by school or district to find performance gaps. And finally, visualization tools and models often work better with aggregated data. It reduces noise and highlights relationships more clearly. For example, a heat map showing average satisfaction by region and service type is much more insightful than plotting thousands of individual responses. Now let's go over the most common aggregation techniques. The first one is grouping, which means breaking the data into smaller chunks based on one or more variables, so you can analyze each group separately. For example, let's say you have a sales data set with information on products, categories, and sales. If you group the data by category, you can then calculate the total sales for each one. That gives you a clear side-by-side comparison across different categories. In this case, we use the sum function to add up the sales, but you're not limited to just totals. You could also use the count function to see how many products fall into each category. Or if you're more interested in the typical performance, you could use the average function to get the mean sales for each group. So depending on the question you're trying to answer, grouping combined with the right function helps turn detailed data into meaningful summaries. The next one is about joining or merging data. This means combining two or more datasets based on a common key, usually a shared column like a customer ID. The goal is to create a more complete and useful dataset. Sometimes the information you need isn't all in one place, it's spread across different tables. Joining helps you bring it all together. For example, imagine you have one table with order details and another table with customer information. If you want to see both the order and the customer's name and city in one place, you'd perform a merge. After the merge, you get a single table that includes everything: order info and customer details. This kind of operation is especially useful in business analytics, where you often need to combine data from multiple sources to get a full picture. Another common aggregation technique is computing descriptive statistics, things like the sum, average, count, minimum, maximum, or standard deviation. You can apply these either to the entire dataset or within specific groups. The idea is to summarize the data in a way that makes it easier to understand and use. Instead of looking at every single row, you get a big picture view that supports better decision making. For example, let's say you have a data set of sales transactions, like the one shown on the left side of the slide. You could add up all the sales to get the total sales overall, or you could break it down by region to see total sales for each area. That way, you can quickly spot which region is performing best without having to go through every transaction one by one. Pivoting means rearranging your data, usually switching between what's called a long format and a wide format. A great example is when you're using pivot tables. They let you quickly explore your data across two or more dimensions. Imagine you have a dataset that tracks monthly sales by region. If you pivot the data, you can turn the region values, like East and West, into separate columns. Now, instead of repeating the region name in each row, you'll have one column for East, one for West, and so on. This format can make it much easier to compare numbers side by side across categories. Besides the techniques we've talked about, there are a few other important terms related to data aggregation that are worth knowing. First, there's something called data roll-up. This simply means taking more detailed data points and combining them into larger summaries. For example, you might roll up daily sales into monthly totals. So instead of looking at every single day, you get a cleaner monthly overview. Then we have aggregation level, which refers to how detailed or summarized your data is. A higher aggregation level means the data is more summarized, like yearly totals, while a lower level means more detail, like daily or hourly data. Another term is temporal granularity. This has to do with time. It's about how frequently your data is collected or reported. So if you're tracking data every minute, that's a very fine granularity. If it's weekly or monthly, that's coarser. Finally, there's spatial aggregation. This is when you group and summarize data based on geographic areas like by zip code, city, state, or country. This is really useful when you're comparing performance or trends across different locations. Understanding these terms helps you better manage and interpret data, especially when you're working with large datasets across time and space.